Okay, good morning, afternoon. This is Calculus, Unit 2.1, Rates of Change and Limits. Your objective is going to be to calculate average and instantaneous speeds, and you'll define calculus limits for function values and apply the properties of limits, and then use the sandwich theorem to find certain limits indirectly. So average instantaneous speed, a body's average speed during an interval of time is found by dividing the distance covered by the elapsed time. So that goes back to what you know as being the distance equals rate times time. We can find all sorts of things by playing with this one. Experiments show that a dense solid object dropped from rest to fall freely near the surface of the Earth will fall at y equals 16 times t squared feet in the first t seconds. So, example 1, finding an average speed. A rock breaks loose from the top of a tall cliff. What is its average speed during the first 2 seconds? So what we're looking for on this one is f of 2 minus f of 0 over 2 minus 0. Now remember, we're using the y equals 16t squared. So this is going to be 16 times 2 squared minus 16 times 0 over 2 minus 0, which is just 2. This gives us 16 times 4 minus 0 all over 2, or 64 divided by 2. So the average speed is 32 feet per minute. That is the average rate within the first 2 seconds of this thing falling. That's the average. So we look at another example. Object is dropped from the top of a tall building and falls 16 t squared feet in the first t seconds. Find the average speed during the first 3 seconds of fall. Same idea, this time we're doing f of 3 minus f of 0 over 3 minus 0. So we get 16 times 3 squared minus 0, because you plug in 0, you're going to get 0, over 3 minus 0. So 16 times 9, so this is going to be 16 times 9 over 3. Gives us 144 over 3, or 96 feet per minute, or second, sorry. I feel like I need to check that last one. That last one should have been feet per second. I have a feeling I wrote minute. Yep. Say, oops, that should be second. Okay, but notice though that in the first 2 seconds of something falling, the average is 32 feet per second, but in that 3rd second, the average becomes 96 feet per second. So very, very quickly is this coming down. But the question is, what are we really finding? That equation there is slope. We're just finding the slope, and at different places, the values are going to be different. But we're finding slope, but from 0 to 2, this is a slope. From 0 to 3, this is our slope. But keep in mind, this is a parabola, so it's not a straight line. But that is what we're doing, is we're finding the slope of the line that goes through those 2 points. But the question is, how do we find instantaneous speed? I wanted exactly 2 seconds. What is the rate of that rock falling? So we're still using y equals 16t squared, but we can't do f of 2 minus f of 2 over 2 minus 2, because we get 0 over 0. And this is not good. We are right there. No bueno. So what we need to do is look at something that is just before we get to 2. You can even do the just after we hit 2, but something very, very close to 2, but it's not 2. So in this case, we're going to do f of 2 minus f of 1.999. over 2 minus 1.999. So in this case, what we have now is 16 times 2 squared minus 16 times 1.999 squared, all over 2 minus 1.999. Now we're going to just kind of jump onto a calculator on this one and do the math instead of writing this all out. So 2 squared is 4, 16 times 4 is 64. And then if we do 16 times 1.999 squared, we get 63.936016. And if we do this math here, 2 minus 1.999, we get 0.001. So now you can see that this is numbers, where it's going at. So again, if we jump onto a calculator rather than just doing all of this itty-bitty math, we're going to get 63.984 feet per second at t equals 2. So you can even claim this one to be that at t equals 2 seconds, it is falling approximately at 64 feet per second. And now you can see going, oh, okay, for 1, the average was 32. For 3, the average was 96. So 64 in the middle of that, not too terribly bad. Okay. So let's try the falling from the building. This time I want to do exactly at 3 seconds. So same thing. Can't do f of 3 minus f of 3, so we're going to take a number very, very close to 3. So we're going to do f of 3 minus f of 2.999 all over 3 minus 2.999. So we have 16 times 3 squared minus 16 times 2.999 squared over, and we'll go ahead and do that math, you get 0.001. So once we play with the calculator, we get 144 minus 143.904016 all over 0.001. And you lovingly put that into a calculator, and you get 95.984 feet per second. Approximately 96 feet per second that this is falling. So there you have that. This is where we're going to stop for day 1, because day 2 starts to go into something different. And so there you guys go.